Hello everyone and welcome to Max. What is Max? It is developed by Cycling74 and over the years it's changed quite a lot, so you will hear me and you will hear others refer to it by a litany of other names which might seem slightly bizarre, but just to give you a heads up, Max MSP and Jitter MSP, they're all just different ways of referring to Max. I apologize in advance for whatever I call it. Today, we are just looking at Max. So, Max is a visual programming language. What does that mean? It means that rather than working with code as text in the same way that you might work with HTML or CSS for any of you that have done any kind of website design or anything like that before, instead we're using visual icons, symbols. We're using blocks and we are patching them together. So Max is primarily about connecting things together and creating kind of simple or elaborate or very complex programs by patching things together. And those things appear as blocks. So today we're just going to be looking at three, more or less, types of block. Let's call them that, boxes in Max. We're going to be looking at objects, messages, and comments. So once we've connected several of these things together, we can send messages or we can communicate between these blocks in a kind of system or network of objects to perform certain operations. And to do that, we need to know a little bit more about what these things do. So an object box performs some kind of action or function in a patch. An object does something. And there are a lot of different kinds of objects. For the most part, they look like this. Sometimes they don't, but don't worry too much about that. There are hundreds and hundreds of different objects in Max. Luckily for us, they are organized in such a way that they are very easy to find, so don't worry too much about it. I think one of the biggest things that beginners struggle with in Max is knowing which object to use and when, but I will show you some tricks for figuring that out shortly. The second type of box that we're going to look at today are messages. Message boxes create messages, obviously, and these can be sent to objects to clarify something. They usually comes in the form of a parameter, or what we call an argument, for an object. So they clarify something that an object has to do. And then finally, we have comments. Now, comments don't directly control the running of a patch, but they are incredibly valuable because they document our patches and tell us, the user, you, very quickly what's going on. And they can help stop us getting lost. They can help give us information about things that we need to improve or things that are working, or just how a certain section of a patch is running. Now, when you come to creating more and more complex patches, these are invaluable because they clarify to you what's going on. And there is absolutely nothing worse than creating a very complex patch that works and then coming back to it 3 weeks later and having no idea why it works. Comments are going to help you out there. So let's dive into Max. Okay, so we've opened a new Max window. This is Max. Welcome to Max. At first, we're kind of greeted with this environment screen. I'm just going to make it bigger. You'll see that we've got some menu bars on the top, along the sides, around the bottom, along the other sides. Don't worry at the moment. We'll go through each of these as we progress. The first sort of section that I want to draw your attention to is this top bar, because this is what lets us create new boxes, new patch blocks. And you'll see as I move along, we've got the object that we talked about just now, we've got the message, and we've got the comment. These are the first few that I want us to look at now. You'll see that by clicking one of these boxes, we create a new block. Let's click a message and let's click a comment. There we go. So we've created these three things. Now I can just highlight them. I can delete them. And you'll see as well that next to each of these objects there is a little shortcut. So N for object, M for message, and C for comment. For today, just for speed, I will probably use a fair amount of keyboard shortcuts to create these. So new object, new message, and new comment. But if you want to just work through using these, then that is absolutely fine. So, first things first, let's start this patch with a comment. I will zoom in a bit just to make this a bit easier for us all to follow. Let's start by saying what we're going to do. What is the purpose of this patch? What is its title? Well, we're going to print hello world to Max's console. Now the console window is this. Now, let's clear that for a second. The console window is basically a message pop-up. It tells us what Max is doing, how it's running, and if everything is going okay or if something's gone wrong. So, let's create a new object and let's call it object. Now, there's no object called object, so the console window is going to tell us that. You'll also see that it's highlighted in red, whereas a object that does exist looks like this. So no error message when I created the metro, error message when I created the object. So it's really useful when you start out to have the console window open, because we can use it to kind of tell us problems or debug as we go. So coming back to our original comment, we know that this patch is going to print hello world to Max's console. Now hello world is a very basic kind of beginning step. It's traditionally the first step in learning any new programming language. You learn how to make that program say hello world. So we're going to do the same thing today, and we're going to use Max. So how are we going to do that? Well, we know that we want to print this to the console. So luckily there is a print object. So I'm going to create a new object and I'm going to type print. And you'll see that the autocomplete recognizes from pretty early on what I might want to do. So PR, and you'll see these are all possible objects that you could use. And it has a little description as well that lets us know kind of what we might want to do, just in case I had that confused with print it or printf. So print now. So this is going to take care of printing to the console. But what is it going to print? Well, if you remember the slide from before, it's going to print a message. So I'm going to create a message, and in that I'm going to type hello world. Now I'm going to patch this together. Now this is how Max works. Remember how I kind of talked about Lego blocks and connecting blocks together? You see these little points? These are patch points. If you think of like a guitar effect pedal and the way that you plug a signal into between pathways, or same on a modular synth, this is the same. So on Max, the signal runs from the output of an object to the input of another object. So this would be the input of the message, and this is the output of the message. And you see that these are helpfully color-coded. So I'm going to patch the output of the message into the input of the print object. Now, watch what happens when we click this. Hello world. Excellent. Now I should just take this opportunity to say that I had a little shortcut when I clicked that. I held the command function to click. If I don't, if I just click regularly, it's going to bring me into the editing this message object. And that's because at the moment our Max Patcher is unlocked, which means that it doesn't function as a program, it functions as an editing thing. Everything is freely editable. Now you see down here in the bottom left hand corner there is a lock button. If I press this, you will see that the edit points will disappear. Now I can't drag any of these things anywhere. This is in kind of, maybe let's call it performance mode. So if I just click on this without the command key, everything works. But I can't edit anything. So I have to unlock to edit things. The shortcut Command E will also do this a lot quicker, so you can get used to that. Or as a shortcut, you can hold Command while you want to activate things. So we've successfully printed Hello World to the Max console. I just want to show you what would happen if I took out these quotation marks. If I print this now, the comma is going to do something interesting. It's going to print it on two separate lines. So having those quotation marks keeps this as a single message printing on a single line. And you'll see that the quotation marks are deleted when it actually prints out. So now this is how we send a message from one section of a patch to another. I just want to show you that there is another kind of signal in Max, which is affectionately known as a bang. A bang is like an impulse. So let's just create a new button object. It looks like this. So whereas before we were activating the message "Hello World" by clicking on it. Now what we're going to do is we're going to send we're going to use a button to control that. So we're going to send a bang by clicking this, and you'll see that it's still going to print out. There we go. So the bang is activating the message, which is then sending the message to the print object, which is then printing. We can see this a little bit more clearly if we add a bang to the output. So we're using this now as a visual display. So you'll see how the signal flows. I'll just make it a little bigger. That when I click this one, you'll see this one light up. So it gives us a little better idea about how the signal flows in Max. Okay, I'll admit, maybe the Hello World patch wasn't the most exciting start to our Max careers. So let's try something a little bit more interesting and a little bit more musical. By the end of this class, we are going to create a harmonic series generator synth, which sounds incredibly exciting because it is. So let's create a new patch. And again, I will zoom in a little bit just so it's a bit clearer for you. And we will bring up the console again. So let's clear that. And as before, let's create a new comment and say what we're going to do. So we are going to play a sine wave. And actually that's not very difficult to do. It's just one object. It's the cycle object. Cycle and then the tilde. So that's us done actually. That's a sine wave. But we have to do a little bit extra if we actually want to listen to it. So we're going to need some other objects which don't quite look like this, and we're going to patch them up. So the first thing that we need is this is our sine wave. We know that. We know what a sine wave looks like. We know what it sounds like. At the moment, we need to give it some more information. We need a pitch. So you'll see that once I type the space, it will tell us what arguments the cycle object accepts. So this first one is it needs a frequency. It needs a pitch. So let's say 440 hertz. There we go. But how do we listen to it? Well, you can see that we have a slightly different looking patch cable here. This is a signal, an audio signal, or this is where the MSP in the old title used to come from. This is the signal processing path. So we need to plug it into something. So what we're going to create is we're going to create a DAC, a digital to audio converter. Max has one with a graphic interface called EZDAC and tilde. And once I type it, you'll see that it converts into this little handy interface button. So I could just plug this in now, but it's a little loud. So what I'm going to do is I'm going to create a gain slider. Now this is gain control. You'll see that when you work with audio signals, most of the objects have this little tilde sign next to it. It's a good idea to get used to typing that on the keyboard, find out where it is on your particular keyboard, just because it crops up quite a lot. So I'm going to type this, and you're going to see that when I create this object, it again is going to change into a user interface object. So there we go. We have a handy little slider. So you can see that I slide this up and down. And now it's just a case of patching this together. So I'm going to plug the output of the cycle into the inlet, the top of the gain slider, and then the out slider. You'll actually see if I widen this, there's actually two. They're a little bit close together. There's this outlet, which we don't need, which is the slider value, and then there's this, which is the actual scaled signal output. So just look for this little signal in parentheses there. That's the key. So we're going to plug that into the left channel, and we're going to plug it into the right channel. And then I'm going to take us out of edit mode, and we're going to play it. So I need to turn the audio engine on, switch it on, and then slowly turn it up. There you go. There's our sine wave. But it could be a little bit more interesting. For instance, at the moment, it's just playing 440 hertz, so an A. So how do we change that? Well, we can send it a kind of message. So I could type a new message object and say, instead of playing at 440 hertz, play an octave below. So play at 220 hertz. And I could send that message, and we listen, and then when I click this button, it will shift down an octave. But now I can't move anywhere else. I'd have to create a new message object. So instead of doing that, let's we'll look at one of these other objects. Let's look at the numbers. So there are different kinds of numbers. There are integers, which is just 1, 2, 3, and so on. And then there's floating point numbers, flownums, which is 1.1, 1.2, 1.3. So we're going to use that, and I'm going to plug that directly into the frequency inlet of the cycle object. And then you can still type in a pitch like that. But then you can edit it. And if I actually make this a little wider, you can drag it by very small amounts and get a smoother transition. So that's given us a little bit more control of our sine wave. Now, you'll remember from the harmonic series generator before that it was nice to kind of have a visual cue on our signal. So let's create a meter object. And what that's going to do is that's going to let us, we're going to take the output from the fader, we're going to plug it into this, and that's going to let us see our signal. Now, I'm a little bit of a stickler for clean user interfaces, so I'm just going to take that back down, and you'll see a lot of these objects have quite clever interfaces. So if I make this taller and thinner, you'll see that it actually switches around the orientation of the meter. So there we go. That's much better. Okay, so if we were to leave this now, I might suggest that you add a little comment here just to tell you what it's doing. And then just to make it a little bit more manageable. There we go. A sine wave generator synth in Max. Okay, so let's take our simple sine wave generator and let's transform it into a harmonic series generator. So the way that we're going to do that is we have our root or fundamental frequency, and we need to explore the kind of simple integer series above that. So the way that we do that is with a multiplication operator. So you'll recall that we need a root frequency, and then to find the second partial of a harmonic series, we're going to multiply that by 2. So what I'm going to do is I'm just going to highlight these objects here, and we're going to copy them. So I'm going to do this by holding Alt and dragging them across. You can also just do this with traditional copy and paste. I'm going to get rid of this. So let's, for example, if I just create 4 of these by copying these, pasting them. So now we have 4. So this is going to be our root frequency now. This is going to be our 1, our first fundamental. And then we need to multiply it. So I'm going to create a new object. I'm going to create a multiplication operator. So you'll see that the asterisk sign is kind of a default in a lot of programming languages for multiplication. And we're going to multiply this by 2. Now it's important that because we want a floating point number, not just a regular integer, that is to say, the frequency might be a floating point value. We're just going to add a full stop at the end of this. That's important, otherwise you'd kind of crop the value. So I'm going to take the output from this number, from our fundamental, I'm going to multiply it, move it here. Let's see what our frequency is, and take it out. So when I pull this back to, actually let's create a message that says 440 just so I can hit that a few times when we need to. So this is 440, our second partial, 880 Hertz. So what we'll do now is we'll copy this for each, connecting them up as we go, and each one wants to come back to the fundamental frequency. So this will need to be changed to 3 to give us the third partial, and this will change to 4 to give us the fourth partial. So again, when we press this, we have these frequencies. So I'm going to go ahead and I'm going to copy this out a few times, and we're going to run the first 12 partials of the harmonic series. Okay, so here we are. I've got 12 partials of the harmonic series, and you'll see that each of them relates back to this root frequency, this 440 in this example, and each one is being multiplied. So it's 440 times 2 times 3 times 4 and so on. And then finally I've got the output from each of these gain sliders sent to a multiplication object here times 0.05, and then that's sent to the audio output. The reason I'm doing that is just to turn everything down, because otherwise when all 12 of these signals are turned up, it can very easily get very, very loud and quite unpleasant. So we can just hear this now. Now this is quite loud, so what I'm actually quite loud and quite a high pitch. So I'm going to take this down. I'm going to take our frequency down to 55 Hertz. So there we go. It's a little bit more mellow, a little bit more harmonious now. So there we have it. Harmonic series generator in Max. Now, there's a few more things we can do just to make this a little bit more interesting, a little bit more useful. The first thing is that I'm going to add a spectroscope. So spectroscope, signal, spectrogram, or sonogram. So when I add this here, what I can do is hook this up to this output and plug it in. Now, if I zoom back in here, this isn't particularly useful to us in its current state. So I'll just turn this audio off a second. The range here is a little bit low. It's not particularly specific. So what we can do is we can change the settings of this object in the inspector, and that's up here on the right hand side. So if I change now, you'll see that we're looking at all of the settings for the spectroscope object. So all of these things can be changed, can be edited. The thing that I want to do is I want to change this display frequency axis from a linear scale to a logarithmic scale, because now this gives us a little bit more detail in the pitch. So when I turn the audio engine back on, you'll see this is a little bit more useful in kind of imagining. As I edit the frequencies, you can see frequencies kind of dropping out. There we go, we just have that 660 Hertz, and you can just see them as discrete peaks on the spectroscope there. Okay, another thing that we can do is we can use a different kind of object to make this interface a little cleaner, a little bit more useful. I'm going to use Max's multi-slider object. Now, you may recognize this when we start to edit it as just being the same as these gain sliders, but it's a little bit more useful to use them all within a single object rather than discrete, separate sliders. So I'm going to go back into the inspector for the multi-slider now, and we're going to change the number of sliders. We're going to take them from, we're going to take 12, because we've got 12 partials, and we need to change the range. We need to change it from -1 to 1 to 0 to 127. And also we're going to change this, the continuous data output. I'm going to turn that on, so it means it's always outputting some data. I can take this up a bit to 12 just to give us a little bit more clarity. And now what you'll see is we've got these lines. I can also use a bar there. There we go. Now, we need a way to get from this output here into each of these. And the way that we're going to do that is we need to unpack this data. So you see, if I create a message here, if I just plug this into the right inlet, you'll see what we get. We get a whole mess of numbers being sent out of this. Now that's not particularly useful to us to know. So instead what we need to do is we need to unpack all of this data. So I'm going to do unpack, and then I need 12 outlets. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and then I'm going to connect each of these up to the slider's input. And there we have it. I can now use this interface to control the volume of each partial in our harmonic series generator. It's quite nice. But this is a bit of a mess. So I'm going to just show you one last trick to clean this up. We're going to select everything in here. And we're going to use a little cleanup shortcut. We're going to route all of the patch chords so they're a lot neater and easier to follow. So I'm going to go to Arrange and Route Patch Chords. And you'll see that this changes into something that is a lot less messy and a lot easier to use. Okay, one final thing, because this really wouldn't be a Max patch if we didn't just throw everything into utter chaos at the last moment. So we have our harmonic series generator. Very nice. We can edit each of these frequencies, the mixes of the frequency, the gain of the frequency in this multi-slider. But what if we could randomly generate a bunch of different sets of mixes for our harmonic series? So I'm going to do this with a few objects. We won't go into them in too much detail, but what is going to happen here, if we think back to our bang message that we looked at right at the start, when I send a bang to this random object, it's going to generate a random number between 0 and 120. There we go. Another one, and another one. Okay, but what we want to do is we want to generate 12 random numbers. So to do that, I'm going to use the Uzi object, which fires off a rapid stream of bangs. So when that receives a prompt, it's going to fire off 12 bangs very close together. And they're going to be captured by the threshold object and put into a list. So we get 12 random numbers. There we go. Lovely. So now if I plug this into our multi-slider, turn the sound on, you'll see that when I hit this bang button, we're going to get a new random set of 12 gain parameters for this. Nice. Very harmonious, very smooth. But what if we want to chop things up even more? So for that, I'm going to add a metro object, or a metronome. And I'm going to say every 500 milliseconds. So what we need is we need a toggle, which is basically like an on and off switch. And when I switch the metronome on, every 500 milliseconds it's going to fire out a bang, which will fire off the Uzi, which will generate a list of random numbers, which will generate a new batch of series mix. So let's control this a little bit. But in true Mac style, because we can just connect things together, what if we connect the output of this random number generator into the input of the metronome? So now every time the metronome clicks, the metronome starts again at a different tempo. Pretty cool. So I hope this has shown you that there are a lot of things that you can do in Max, and it can be a very simple tool for creating, our hello world. We can generate simple sine waves, and we can generate more complex things by just simply copy and pasting, really. So yeah, welcome to Max.